This is Dr. Santosh. So one of my students texted me, sir, I'm feeling difficult to write the electronic configurations. So please guide me like that. He texted me. So today in short video, I'm going to show you how to write the electronic configurations for the atomic elements 1 to 20. Right? Even you don't know anything, just listen to the class. After that, this 20 minutes or 30 minutes class, you will able to write electronic configuration for any kind of element. I promise you, right? Just listen to this class carefully. After 20 minutes, you can write atomic configuration for any element in chemistry. Okay. For that, we need three concepts, three very small concepts and easy concepts. Those are atomic numbers, orbitals, Euler chart. If you know these three, you can write the electronic configuration for any element. So these are very easy also, right? Atomic numbers, first I will list the atomic numbers from 1 to 20. I will list the orbitals, what are there. And with the help of this Euler chart, we are going to write the atomic numbers for all the elements, right? Today I will list the atomic numbers from 1 to 20. First I will write the atomic numbers, right? Hydrogen 1. What is atomic number, what is molecular weight, and that and all we will discuss later. This class just focus on how to write the electronic configuration. Just focus on how to write the electronic configuration, right? So first atomic number, hydrogen is 1. For each element there is a unique atomic number, right? Hydrogen is 1. He stands for helium. So this is 2. Atomic number for helium is 2. And Li stands for lithium. Atomic number for lithium is 3. And Be stands for beryllium. Atomic number is 4. B stands for boron. Atomic number is 5. C stands for carbon. Atomic number is 6. N stands for nitrogen. Atomic number is 7. O stands for oxygen. Atomic number is 8. And fluorine is 9. And neon is 10. Just remember this. These 10 atomic numbers. I repeat, hydrogen is 1. Helium atomic number is 2. Lithium atomic number is 3. Beryllium is 4. Boron 5. Carbon 6. Nitrogen 7. Oxygen 8. Fluorine 9. This is neon 10. Okay. So atomic numbers you are clear. Just these elements. This is the atomic number. Right? To write the electronic configuration, you are clear with the first step. Next, going to the next step, we have the orbitals S, P, D, F. Right. So to write the atomic configuration of any element, we need to get the little idea about these orbitals. So what is S, what is P, that I will go in depth to the IIT JEE advanced level. First, to write the electronic as a beginner, as a student from zero basics. So just you want to learn the atomic configuration of the element. So these three concepts is enough to write the electronic configuration for any element. So for that, right now I am explaining the orbitals S, P, D, F. And also remember, S orbital can hold only 2 electrons. S orbital can hold only 2 electrons and single box will come. Okay. Electrons I will write like this. Electrons I will like this. Instead you can use double arrows also. 2 electrons. So S orbital just write one box. Each box contains 2 electrons. P orbital just write 3 boxes. Why it is and everything I will tell you later. Right now our aim is to write the electronic configuration for any element. That's why just remember what I am teaching now, and after this class I promise you will write the electronic configuration for any element, right? So P orbital there are 3 boxes. Each box can hold 2 electrons. Thereby a P orbital can hold 6 electrons. Next, coming to the D orbital, there are 5 boxes. We are not supposed to call them as boxes, but for your better understanding, I am using simple English and friendly language, right? So 1, 2, 3, 4, 5. So for D orbital, there are 5 boxes. Each box can accommodate 2 electrons, right? Or there are 10 electrons. Likewise, F orbital, there are 7, right? 1, 2, 3, 4, 5, 6. So it can accommodate maximum of 14 electrons. So just now remember these atomic numbers of the element and the orbitals. Orbitals are SPDF, S orbital 1 box, P orbital, these are called actually degenerate orbitals. P orbital 3 boxes, D orbital 5 boxes, F orbital 7 boxes. And each box can accommodate 2 electrons. So S orbital only 1 box is there. That's why it can accommodate only maximum 2 electrons. I repeat, S orbital can accommodate maximum 2 electrons. P orbital can accommodate maximum 6 electrons. D orbital can accommodate maximum 10 electrons. F orbital can accommodate maximum 14 electrons. And the third concept, Euler chart. Euler chart, see the arrow marks. If you follow the arrow marks while writing the atomic configuration, first you need to write the 1s as per the arrow marks. It is very easy to draw from 1s to 8s, and then leave one space above, leave one space behind, and start from the 2p, come from 2p to 7p, right? While writing the D, so leave 2 here, leave 7 here, start from 3 to 6, right? 3, 4, 5, 6. And while writing the 4f, leave the 3 spaces, right? Write 4f and 5f. So, and give the arrow marks. This is a kid's play. Very simple to draw this Euler chart, right? Right? So I'm going to start. Starting the electronic configuration. I'm going to write in the electronic configuration. So I suppose, I think you are clear with the three concepts. The atomic numbers, these are the orbitals, this is the sequence. So first 1s will come, then 2s will come, see 1s will come, 2s will come, 2p will come, 3s will come. So we need to go like this. We need to go like this. See, carefully observe the dots. We need to go like this. First 1s. After that you need to go like this, right? 2s will come. Then you need to come like this, right? 2s. See, after that you need to go like this. 1s, 2s, 2p, 3s. I repeat. First 1s. You need to go like this, right? So 2s will come. Then again, after that you need to go like this, right? 2p will come. Then 3s will come. After that you need to go like this, right? 3p will come. 4s will come. This is the sequence, right? To avoid confusion, I am removing this. Right? Right now I am starting the electronic configuration from the element. First, I will write the atomic number. So, first I am writing the element hydrogen. What is the atomic number of hydrogen? 1. Okay, fine. Then, go to the Euler chart. Right? First, what we need to write? First, you need to write 1s. Okay. 1s. How many boxes? So, 1 box. Okay. So, how many electrons? And one more simple thing here equal to atomic number equal to number of electrons. Atomic number equal to number of electrons for neutral atom. So you can ask a question, sir, what is a neutral atom here? There is a difference. Neutral atom means just I say H, that is a neutral atom. If I say H plus, that is a charged atom. If I say H minus, that is a charged atom. So right now, first we are writing the electronic configuration for the neutral atoms only, right? So, and one more thing, helium atomic number is 2. So as I said, atomic number equal to number of electrons for neutral atom. So helium atomic number 2, so it contains 2 electrons. Lithium atomic number 3, it contains 3 electrons. Nitrogen atomic number 7, it contains 7 electrons. Neon atomic number 10, it contains 10 electrons. So hydrogen atomic number 1 is 1, it contains 1 electron. So we write the electronic configuration like 1s1. In box, we'll just represent 1s1. As this is the electronic configuration. See how simple this is, right? First write the element, atomic number, go to the Euler chart, write the orbital. So atomic number 1 means there is 1 electron. So write 1s1. So s orbital contain only 1 box. Fill that electron into this box. So hydrogen 1, 1s1. Electronic configuration is over. Then coming to the helium. So helium, what is the atomic number? 2. That means how many electrons are present in helium? 2 electrons. Right? So first what will come? 1s orbital will come. Right? How many electrons are there in helium? 2 electrons. So we need to write 1s2. Right? So 1s orbital means 1 box. How many electrons? 2 electrons. 1 electron in upward direction, just convention. Second electron is downward direction. Very simple, right? Then coming to the lithium. Right? What is the atomic number of lithium? 3. Okay? 3. First to write 1s. S orbital can accommodate how many maximum electrons? So 2 electrons. Write 1s2. S means just 1 box. So write the 2 electrons. Right? So we are left with 1 more electron, isn't it? 1s2 is filled. So but there are 3 electrons. We are left with 1 more electron. So after ns, what will come? According to Euler diagram. Right? So very simple. See, 1s. After that, what will come? 2s will come. Just write 2s here. Right? So we are left with 1 electron only. Just put 1. S orbital means 1 box, right? upward direction. Lithium 1s2, 2s1. So coming to the beryllium. Beryllium atomic number is 4. There are 4 electrons in beryllium. First what will come, see, 1s2, right? After that what is coming? 2s, right? So 1s2, we need to add 2 more electrons. So 2s2, see, 1s2, 2s2, beryllium atomic number 4, 4 electrons. Electronic configuration according to Maillard diagram. First we are taking 1s, then we are taking 2s. So 1s2, 2s2, right? Next coming to the boron. Boron atomic number is 5, right? How many electrons are there? 5 electrons, right? So how will you write? 1s2, right? 1s2. So it is going like this. 1s2, next 2s2, right? 4 electron. We need to fill one more electron. So how, what I said, always go like this way, right? So 1s, 2s, after that what will come? 2p will come. 1s2, 2s2, 2p1. 2, 2, 4, 5. So boron contains 5 electrons, right? Now I will write for the carbon. Carbon atomic number is 6, right? So what is S here? What is the first one here? 1s. S orbital can accommodate how many electrons? 2 electrons. 1s2, right? Next, what is the orbital here? 2s. 2s2. Next, what is the orbital here? 2p, right? So 2 to 4, we need to add 2 more electrons. 1s2, 2s2, 2p2. Okay. So s orbital contains one box. So there are 2 electrons, that's why we are filling those 2 electrons. S orbital contain one more box, so we are filling those 2 electrons. So p orbital, as I said, to check here, how many boxes I told? P orbitals, 3 boxes. Those are degenerate orbitals. We are not supposed to call them as boxes, but to understand you better, I am using the simple language. Okay. So here 2p2, 2 electrons, right? So first, there is a rule that I will discuss later. Right now, I don't want to confuse you using the terminology more. Just p orbital and d orbital, what you do is, while writing the electronic configuration, first fill all the boxes with single electrons, then only pair them up. I repeat, while filling the electrons in the p orbital, first fill the electrons in single boxes, right? Give each electron to each box, and then if fourth electron is going to come, then only pair up. Okay, that you will come to understand, right? So carbon, then it is nitrogen. So what is the nitrogen electronic configuration? So first 1s orbital contain how many electrons? 2. Next 2s2. Okay. So we are left with 3 more electrons. See, 1s, 2s, after that 2p is coming. I told you always go like this way. So 1s, 2s, 2p, right? 2p3. Okay. So 1s orbital is 1 box, 2s orbital is 1 box, 2p orbital is, so give. So I told you first fill all the boxes with single electron, then only pair them up. Okay. So I'm going to rub this. So few students to take a screenshot of that. Right now till nitrogen I have completed. Right now we are going to write the electronic configuration for oxygen. So oxygen atomic number is 8. That means there are 8 number of electrons present in oxygen. As I told, atomic number equal to number of electrons present in a neutral atom. Here oxygen is a neutral atom. It's not O minus or O plus. That's why just oxygen there are 8 electrons. I am going to write the electronic configuration for this. Just write 1s orbital, 1s2, okay, 2s2, 2. So 1s orbital holds 2 electrons, 2s orbital holds 2 electrons, then 2p. So we are left with 4 more electrons. 1s, 2s, 2p, right? 2p4. I repeat for oxygen. First write 1s. So always go in this direction. So 2s. S orbital can hold only 2 electrons. That's why 2s2. So here come to 2p, right? 2p or 2p4 will come here. Why? P orbital can hold maximum of 6 electrons, but here 4 electrons only coming. I repeat, p orbital can hold maximum of 6 electrons, but here we are left with only 4 electrons. That's why I am writing here 2p4. So now write the boxes. So 1s, 1 box. How many electrons? 2 electrons. Okay. 2s. S means only 1 box. S orbital holds only 2 electrons. So here p orbital, 3 boxes. Here observe carefully. So first I will give each electron to each box, right? Then only electron will pair up. See, always if there are 2 boxes, 2 electrons in a orbital, always position them in opposite directions. I repeat, if there are 2 electrons in an orbital, always position them in, it is always position them in opposite directions. Clear? Next, coming to the fluorine. Fluorine atomic number is 9. Coming to here, first 1s, right? S orbital can hold 2 electrons. Then 2s, it can hold 2 electrons, right? Then 2p, 5, right? 2, 2, 4, 5. Fluorine atomic number is 5. So there are 9 electrons. So right now we are going to write the orbitals. 1s, there are 2 orbitals. 2s, there are 2 orbitals. And 2p, what I told you, first write like this, right? Give each electron to each box and only pair them up. So here 3 paired, but it is 2p5. We are still left with 2 more electrons. So pair them up in opposite direction. That is the electronic configuration for fluorine atom, right? So next, neon, 10. Okay. So 10 means there are 10 number of electrons. Go to the Euler chart. So take the reference from Euler chart. So 1s2, okay, 2s2, 2p6. Right, correct, right. 2 to 4, 4 plus 6 is equal to 10. So I am writing the now orbitals. 1s is one box, it holds 2 electrons. 2s is one box, it also holds 2 electrons. 2p, there are 3 boxes, that means 3 degenerate orbitals, right? First, right, gives each electron to each box and then pair them up in opposite direction. That is the electronic configuration for neon. See how simple it is. Is there any difficulty? Right? Atomic number 1 to 10, you know. You have studied in 10th standard or 9th standard. If you don't know, also just you can by heart now. Take a screenshot it and work them on these atomic numbers 5 minutes. Then you will get it right. What is the difficulty? First atomic numbers you know. Atomic number equal to number of electrons. If atomic number is 4 means there is 4 number of electrons. Then go to the, so you have an idea about the orbitals. There will be SPDF. They are continuous letters. Right? Very simple SPDF. Right? Then SBDF. Continuously like SPDF, SPDF, SPDF. You just by heart 3 to 4 times, then the orbitals will come. And then S orbital contain single electron, single box. P orbital, remember this also, 3 boxes. D orbital, 5 boxes. F orbital, 7 boxes. Clear, right? Each box holds 2 electrons. So S orbital, since only it is having only one box, it is having only 2 electrons. P orbital 3 boxes, 6 electrons. D orbital 5 boxes, 10 electrons. F orbital there are 7 boxes, 14 electrons. Right? Then go to the Euler diagram. So take the reference of it to write the electronic configuration. So now please take a screenshot. I am going to rub this. We are going to write the electronic configuration for 11 to 20 molecules now. Okay. So till 10 we have completed. Now we are writing for 11 to 20, right? Sodium is atomic number is 11. Okay. Magnesium atomic number is 12. Aluminum atomic number is 13. Silicon atomic number is 14. Phosphorus atomic number is 15. Okay. Sulfur atomic number is 16. Chlorine atomic number is 17. Okay. Argon atomic number is 18. Okay. Next, potassium atomic number is 19. Calcium atomic number is 20. Okay. So Na stands for sodium. It's sodium. Mg stands for magnesium. Al stands for aluminum. Si stands for silicon. P stands for phosphorus. S stands for sulfur. And Cl stands for chlorine. As argon 18, potassium 19, calcium 20. Okay. So now I will write the electronic configuration for the elements 11 to 20. Right. 11th I will write. Then phosphorus I will write. Then calcium I will write. So you students please practice 12, 13 and 14, 16, 17, 18 and 19. Right. Right now I will write the electronic configuration for sodium. Okay. Sodium atomic number is 11. And right, take the 11 atomic number means there are 11 number of electrons. Take the help of the Euler chart and write first 1s2, right? Next 2s2. Are you following? Any doubt? Please comment on the comment section. I will get back to you immediately. Okay. Then 1s2, 2s2, and then write 2p6, right? 6, 8, 10. We are left with one more electron. See, take the help of the Euler diagram. After 2p, what is coming? You no need to by heart anything. Take these 3 reference and you can write the electronic configuration for 100th element also, right? So after that 2p, what is coming? Here 3s is coming, right? So we are left with one more electron. So I am going to 3s1. Clear? So 1s2, 2s2, 2p6, 3s1. This is the electronic configuration for sodium. After that, I am going to phosphorus. You student, please practice this 12, 13 and 14. Right? Phosphorus, it is atomic number is 15. Okay. So as usual, 15 electrons, 1s2, 2s2, 2p6, right? 3s2. So here I want to give a clarification whether it is 1s, 2s or 3s or 5s or 6s, right? If s orbital means, don't bother about these numbers that are present between the s, p or d. Blindly remember, s orbital means 2 electrons, p orbital means 6 electrons, whether it is 4p or 8p, 5p or 6p. P orbital means 6 electrons, right? D orbital means 10 electrons, f orbital means 14 electrons, right? So I am writing 1s2, 2s2, 2p6, 3s3, 4, 10, 12. I am left with 3 more electrons. See here, after that 3s what will come? I told you always go like this direction. Okay. So after 3s what is coming here? 3p coming here. Clear? After 3s, 3p coming here. So just write here 3p, right? We are left with 3 more electrons. So 3p3. This is the electronic configuration for phosphorus, right? I am giving the orbital convention. So 1s 1 box 2 electrons, 2s 1 box 2 electrons, 2p 3 boxes, so 6 electrons, 3s 2 electrons, 3p3, so 3 electrons, right? So 17, 18, 19, 16, 17, 18, 19, you people please practice. Then I will go for calcium 20. Okay. So 1s2, 2s2, okay, 2p6, 3s2. After 3s what is coming? What is coming? 3p, right? 3p6. Okay, I will count 2 to 4, 4, 6, 10, 10 to 12, 12, 6, 18. After 3p what is coming here? After 3p what is coming? 4s. So 4s2. Okay. This is the electronic configuration for calcium. Okay. So finally, I will write the electronic configuration for the element 30. I am going to stop this class. I request you student, please take a screenshot of that, right? So now I will write the electronic configuration for 30th element and I am going to stop the class, right? Just carefully observe. Atomic number of element zinc is 30. Okay, you are going to learn anyhow what atomic numbers. First 20 is very important. First 20 is very important. It's better. I will make you to learn all the periodic table with simple tricks, with awesome tricks, right? Right now, just remember zinc is 30, right? First what will come? 1s2, right? 2s2, 2p6, 3s2, okay? 3s2, 3p6, right? Then 4s2. Then what will come? I told you go in this direction. I told you to go in this direction. So after that 3d will come. Okay. 4s2, 3d. So just count 2 to 4, 4, 6, 10, 12, 18, 20. So I told you d orbital can accommodate maximum how many electrons? 10 electrons. So 3d, 10. This is the electronic configuration for zinc. See how simple it is. Everyone knows atomic number. You need to just remember just 4 orbitals. In that you need to remember s orbital means 1 box, p3, d5, f7 boxes. That means degenerate orbitals. Just this simple modular chart. See, first write 1s to 8s. Then leave 1 space. Write 2p to 7p. Leave 2 spaces. 3d to 6d. Leave 3 spaces. 4s, 5f. And arrow mark in this direction. And one thing you need to remember, always go in this direction. Right? So this right now I will give the boxes and I am going to close the class. 1s2, 1 box, 2 electrons. 2s2, 2 electrons. Right? 2p6, 6 electrons. Always first fill with half filled, right? Then only pair them up in opposite direction. Next 3s, 2 electrons. Next 3p6 I am writing here, right? This 3p6 I am writing here. 3 boxes, that means 6 electrons. 4s2, 2 electrons. D means 5 boxes, right? 5 boxes. Always first make them half filled, then pair up, right? This is the electronic configuration for zinc 30. We can write for 50 also, we can write for 70 also. Practice for the elements, practice for maximum number of elements, then you will get a good grip of it. I hope you enjoyed this class, and tomorrow soon I will release the next video with very good content. Thank you. If you like this video really, kindly share and subscribe. And thank you very much.